Hello everybody, welcome to another stream. How are we all doing? So, last stream, which was on Thursday, last week, we nearly got this whole sort of, where's the sort of, is it called in the design folder, was it? Docs, yeah. So we nearly got this sort of LOD cluster system, just sort of the initial version working for it. So we have the ability to effectively paint within this sort of 256 cubed volume and build up essentially a volume filled with spheres and have them sort of simplify. If the spheres are surrounded by other spheres, right, they can simplify into larger spheres, and we have levels of detail and things like this. But we've built everything in a sort of in a buffer which is large enough to store 256 cubed worth of spheres. And then we sort of realized, like, hang on a minute, we actually didn't really use 256 cubed of memory. So then we're currently trying to get this shader off the ground, where it takes this piece of memory and effectively just moves it into a persistent memory where it's got maybe a bunch of different volumes all sitting next to each other in memory of different sizes. So that's what we're trying to get off the ground today. And then when we have that, we should be able to actually render these things and work on other features. Hey there, Gaskia, welcome. How's it going? Welcome to the stream. So I forgot what wasn't working about this. So this is the make persistent shader, where it gets that LOD cluster tree, and it starts off at the leaf nodes in a multi-threaded manner. Each thread gets a node, and it sees if we want to keep the node or not, and then it will simply copy it to it will allocate a new node and then copy it to persistent memory. Now, I forgot what I did. I added some print statements somewhere or something. There was something that told me that this wasn't working right. Oh yeah, we checked it in RenderDoc, and we looked at the final volume data, the volume information, and it was just absolutely wrong. So we've got to figure out why. We should add a print statement. On what am I working on? Well, we're currently working on trying to render a whole tons of spheres at the moment. That's what we're working on. So this is the big system that does that, you know. So we're just trying to get it up and running because it's a bit complicated. So it's taken a bit to get it complete. I need something like this. Make persistent, that's what I need. So I need to know when we keep a node and when we don't keep a node. Right, keep node this guy. We'll uppercase that. So this is when we go up the tree. So I want to say node goes to parent node. Okay. So see how many of those print out. We should see some traversal. Right. Apparently it's keeping a whole bunch of them. I don't see any of the printing code that says it's going to... I don't see any of the traversal code here. Let's comment out that keep. Right, that's buggy. That's probably the issue then. We're not going up the tree. That's the reason why I wasn't allocating enough nodes. So there should be some visit bits. What distro am I using? I'm using Manjaro. Because Arch-based distros are the way. Every time I use Ubuntu, it always falls apart and dies. Not fun. Or you can't get some piece of software and you have to mess around with too much stuff. So why aren't we allowed to go up the tree? If the node, if you have a parent, there's some safety check thing here. Yeah, they're the range, that's fine. I chose Ubuntu and after 30 minutes I switched to Arch. Awesome. Yeah. There's a weird thing, you know, they have that error reporting system. It just, for me, most times when I install Ubuntu, every time I tried it at least, and you know, when I actually had an install of it, you'd always get that sort of thing saying, hey, something has crashed in the background and it's some like background process that you've not really heard of. And that those things just keep popping up all the time. Tons of other little things as well they want you to report. Never good. And they did all that snap package stuff where they want you to use snap packages and the theming's not all working, and it's like, come on guys. You know. So yeah, Arch-based distros are the way. I have done many Arch installs in the past, but you know, it's just easier just to get something that just installs and comes. That's why I just use Manjaro. But I had the Arch installer improved. So something to do with my visit bits. Source. That's right. Did I change any of this code in the previous one that goes up? Right, let me grab this one and just compare them side by side. Something, I could have not copied something. Right, so this line and this line. Yep, this line and this line, that's the same. This is just named differently. Very nice. Plus that, yeah. Or the bit, yeah, move the bits and good. Awesome. So we never go in here for some reason, so I want to see the bits. Right, can I move this outside here? Just to make sure they're actually getting inside this statement. Right. That's good. So, but we're not actually saying all the bits have been, visit bits have been visited. Why might that be? Yeah, I think did the children bit set get messed up in the previous shader? What do we do? Here it is, I clear the bits off. Remove the visit bits for the next shader. There's 8 bits there. That's where the children sit. And that's where the visit bits go. And here's the new set of bits. We put them past, that's 8 times 2, that's 16. So drop them here. That's where it drops those. So mm, um, right. There's the final. Stores in the destination. All right. Right, so how isn't this working then? I need to view the visit bits somehow. Maybe we'll go up when we clear. Hmm. Um. Yeah, I can't believe nothing gets past here. It's the most confusing thing. Wait, when does this happen? Does this happen on all nodes? So in a previous shader, when we modify this, it goes, every cluster gets access to this, right? Every cluster node clears the bits out. I think that's right. Right, let's print them out in hexadecimal here. We'll just print out the visit bit or the bit, they call it child bit set. So that's just 0x. That. Voila. So I want to print out like it's the parent one, isn't it? Let's try that out. Whoops. Okay, see how that goes. Right, FF, FF, they're on. And they're on, but the top ones aren't on. So I'm wondering, are these visit bits getting cleared? Yeah, so if each sort of byte is the same as the next byte, then that might be a problem. Maybe we should do the checking before or something, like here. Oops, here. Right. This is fine. This is what we expect, right? These are the children bits. There's 8 bits to represent how many children and the parent there are, or each of the children that exist in the 2 by 2 by 2 cluster of spheres, right? And these bits represent if they've been visited or not, and these ones represent what the nodes the children will look like after the copy, the persistent space. So we're going up the tree and we'll mark all the visit bits. Ah, we need to AND something. No? Oh, I need to AND some bits. These need to be ANDed as well. Yes, we need to AND the lower bits. Because we shifted them over, so they're sitting at this position from the visit bits. They've moved over to here. And then, problem is we haven't ANDed them. So these F7 will be here, you know, and it just wouldn't be equal exactly. So we need to AND it to the first byte. So we're going to keep the first byte. So I should actually move that up to the other shader as well, just in case we ever put anything in the higher bits. Right, so that should get the other print working. This print should now work, and this will show that we're traversing up the tree. So yeah, the GP crashes, I'll be right back, but you know the drill, should be alright. Excellent. Now, I think the whole thing is being built properly. So we'll comment this out, and we can prove this by going into render doc and just seeing how many nodes we've got, and go from there. Okay, so we'll this make persistent. Shoot. Okay, so it's about 0. See, I don't know why it does this, 0.22 ms. And then in the next shader is 0.079 ms. I don't know why this stuff takes too... why it gets so noisy. That could be OBS, right? OBS is running at 30 frames a second, and this is running at, or trying to run at 60 or whatever, isn't it? So maybe that's it. So every other frame it's getting hogged by OBS or something dumb like that, right? That would make sense. But anyway, I was hoping for this shader to run maybe quicker than this, because it's kind of a show me how well my next shader needs to run. But maybe it's fine. Maybe it's fine. So let's take a look to see if we've actually achieved what we want. So we've basically copied from a sort of, this is where we temporarily build new volumes in, we paint it into a 3D volume, simplify it, and all this stuff, right? And now we've copied it, and we've realized, hey, we only use this much space out of this whole much, so we sort of copy it out to a persistent place in memory that we've allocated. Bear in mind, we haven't got some special allocator yet, we're just chucking it into a new buffer. that will come later. But let's just double check. Let's go to render doc. And let's see. Let's just see some numbers. If the numbers should be alright. So what we're specifically looking for is we've got a volume data structure. Inside volume, this one. It's going to tell us a couple of things. How many leaf nodes are there and how many non-leaf nodes are there. Now we should have more leaf nodes than we have non-leaf nodes, right? And as long as they're looking like they're quite a big number, then probably correct. We cannot tell. Like, we've been able to have a sneak peek by looking at some texture, but we can't tell until we actually try and render it. But I've just got to try and find the shader. Is this the one? Make persistent. Here we go. So make persistent, we do some writes out to that buffer volumes. Damn it. I press save here, man. Saved that thing. Right, so we're just gonna want like an array of like 6 units or something dumb like that. So volume 3 8. Right, so looking at it, right, you got this guy, which is the midpoint cursor. The midpoint cursor so the midpoint cursor should just be plus leaf nodes count. We'll take a look into this because we've allocated from the 0 position. Allocate index plus the final leaf nodes count. So it's as if like that final leaf nodes count is not equal to leaf nodes count, then something is wrong. Right, we've just hard-coded to 0. So something appears to be wrong. So these two numbers should be the same, but we end up with more nodes. So I think there's a little bit of logic wrong. But we do have more leaf nodes than we have non-leaf nodes. And that is amazing. So this number has to be more, right? Because we're actually underflowing here, and we should have crashed the GPU, but it hasn't. So this midpoint cursor needs to be more because the leaf nodes are on the left of the midpoint cursor and the non-leaf nodes are on the right. So here's the midpoint. Leaf nodes go down there, non-leaf nodes go there. Yeah, so when we so how the hell this says get rid of. You never know. I don't think we ever actually know. This gets rid of a child if it's completely surrounded by other children. Right, and that's what this code is doing here. It's symbolizing here basically. Then the other time when there could be... Wait, so what have we done? We've taken away too many? Right, so when we make it persistent, the thing that we use is we say, hey, if so what we're saying here is if the Right. So if the node has any children, or if it has any spheres on the volume. Whereas up here, this removes that child from the bit set. So you check all 8 children at once going through here, isn't it? Then it decrements and takes it away. It feels like it's taken away too many though. No, because that number's not as big as this one, because this one is right. So I've somehow got to build up. So this shader, when it sort of simplifies the tree by starting off with the leaf nodes. Well, so you find out based on the child index whether or not it is a leaf node. Yeah, this might not be correct. It's not correct. So the first ones are going to be leaf nodes and you'll take away. But by taking away the let's figure out all these numbers, how these numbers are wrong. So if we go back to here, you've got this midpoint cursor, leaf nodes, and then non-leaf nodes count. The midpoint cursor, because we just allocated the new buffer at the 0 position, it should be the same as leaf nodes count. So because it's not the same, it means that that final count is too little, and the number of actual leaf nodes that got kept. And that's a lot of nodes. Is it? Hey there, Ans. Yeah. Ains36, how's it going? Best way to learn code, I see Code Academy, but are they actually any good? Right, game sounds fine. I thought something popped up. Best way to learn a code? Like, what do you want to learn? Like, entirely depends. Like, programming is a very big thing. You know, it's just best if you have an idea of what you want to get into, really. Cluster tree midpoint cursor. Plus leaf node. So this means then that the midpoint is let me easier to draw this thing up. Here's a drawing already. So we start up from here on these leaf nodes, and this one as well. So these are all leaf nodes. I've got a thread on each of these guys. Turns out we're not keeping this one. We subtract. So we've got 5 leaf nodes, we subtract one, we've got 4 leaf nodes. Um, so we subtract when we've got 4 leaf nodes, that's correct, right? But if you don't keep that one, and that one, and that one, you've got subtracted all of these leaf nodes. You've actually got, instead of 5, you've got 2, even though you took away 4 from 5, right? Because you got these 2 here as leaf nodes. So I think there's stuff like that going on. So the problem is, how do we work out? And also probably got another issue where you could have completely cleared like you could have deleted all of these guys here, right? This one also gets deleted, right? So you would, initially you had 5 leaf nodes, right? You took away 4 here, right? And then, actually, you shouldn't have taken away 4 because it should have been 3 or something, left with 2. Now you'd have to remove this one. Because this would be a new leaf node. And then you'll be left with 2 again still. Yeah, so maybe don't worry about the... difficult to think about. We'd love to get into game dev, start simple like Python or C#. Sure. Well, I'm not too familiar with that side of things, so I can't really suggest anything. What I can suggest from the C side of things is there is a library called Raylib, which is a very nice, easy API, simple API, works across all these platforms and has all these different language support. But it's written in C, and you can use the C API because it is dead simple, and it comes with all these examples. Has to do basic things of just putting up images or title screens and doing like a 2D camera, and the whole code is all here. You just copy paste and basically glue together and learn from there basically. But yeah, highly recommend. But perhaps that might be a bit too much in the deep end if you still don't understand if statements, but maybe it's fine. Maybe it's right. So what's the way that we can keep the number of leaf nodes? And also, is that... So we got 128 cubed. That's the most number of leaf nodes, right? 2 million. So having 400,000 isn't bad. Okay. Seem like good numbers. So as we go up the tree, we just need to keep note of like, hey, you are now a leaf node. And that's basically it. And you'll know when to take from leaf node and non-leaf node. Something like, is that right? So you'll know these are leaf nodes from the get-go. And then when they get deleted, so when's the times they get deleted? Yes, this code here, and maybe if they don't have any children, so we'll have to change it there as well. Yes, I think we should be able to keep track whether this thing is a leaf or not. So you know it's a leaf by if it's a negative index to begin with, but anything after that, it's a leaf so long as all of the children don't exist anymore, something like that. So I have a boolean is leaf. Be careful here. Right, node index less than 0. Okay. Now, that is only true because we've allocated it in that way. But now we're going up the tree and sort of we need to keep track. But as we're deleting nodes, that's not going to be a way that we can check. So the way we ensure that we keep the leaf, or is the parent is a leaf node, the only way we know that's true is when children nodes. So you're going over this node, 8 threads for this, looking over the child nodes, and you're checking. Well, you can check if they've got children. And if they haven't got... Wait, you have the child node here. Oh, no, there's a very easy way to tell this. Very easy way. Because the child node would have already been acted on, which means you simply just check. Child node bit set, children bit set. You're checking if the final this one. So this child node that we're deleting doesn't have any children, then it's a leaf node. So when we have these are all leaf nodes that we start off on, we delete, leaf node, leaf node, leaf node, leaf node. Now this one becomes a leaf. So we have to make sure that when we so this node here, okay, that's correct. So this node here, when we have, how do we do it? So if we find out that it has no children anymore, what we have to do is we have to say, hey, this is now a leaf node and it's now no longer now it is a leaf node and is no longer a non-leaf node, right? All children have been deleted, making this node a leaf node, right? So that's how we can determine those numbers there a bit better. Now I don't know if there's another thing that we're missing. Hey Cat Payne, welcome back. How you doing? And you check it really looking to get potential career shift. Love to learn function programming as the my area of programmers for different things. You can dive in your own time. Cool. Cool, you understand if statements. Nice. Nah. I know, man, this stuff is complicated. Yeah, bit sets are not so bad. But they are crazy when with the system that we're trying to do. But we should have something up and running soon and we can just tweak it and make it simpler and better. Yeah, man, definitely. Want to try and get something up and running before I go on holiday. Oh, that's the aim. But yeah, just hoping this thing will be fast enough and then we can move on to some of the other things. I'm just trying to get it to render. Yeah, trying to get it to render fast enough. Maybe do some occlusion buffer stuff, maybe. You know, probably get multiple volumes with different little shapes in there. Have a bit of a play around. It's gonna be cool. So I've got to figure out how do we calculate the number of leaf nodes and non-leaf nodes precisely. So we've got the case now where we delete stuff and this one becomes a non-leaf, right? I think. Is there any other problem? You delete these, you start on these leaf nodes and traverse up the tree, right? Turns out you've deleted all these buggers. And then you found out, hang on a minute, I am actually don't have any children anymore, so I negate the non-leaf node and make myself a leaf node, right? In terms of the count system, just the counts. This stuff here sets the final high bit. That's right. Just probably do an else statement, to be honest. Radio. Radio. I don't know if there's anything else. I think that's what was missing. Is correctly. Yeah, I think we're subtracting too much and not making stuff leaf nodes when they needed to be. Okay, so the stream dies. I'll be right back. You know the drill. Please work. Okay, still runs. Now, if we run it in RenderDoc, we're going to look at that piece of memory again, and hopefully those numbers are exactly the same. If they are, it's correct, and we can move on and try and get something to render. If not, we've got to go around again and have volumes. Right. Oh, now the number's bigger. Twice the size. In fact, twice the number of nodes. Or 40,000, 400,000 more nodes, nearly twice as much. Which is bad. So this number here says the midpoint cursor. This number here says the number of leaf nodes. Oh yeah, dangling nodes. Yeah, dangling nodes. Yeah, that's just solve the dangling node problem. So if one of these has children nodes, sorry, if this is This just has spheres painted on it. And then they got rubbed out or something, the node would still exist. So that would, you pass by, it says, does it have any children? That's going to do it way too much, damn it. You have to say, yeah, if this thing had children and then doesn't have any children. So if it had children, now it doesn't. So that's probably part of the issue, but I think there's another one where we also delete it. A node will fully get deleted if it has no spheres. So if it has no spheres there, wait. Yes, that makes it a leaf. But the node also gets completely removed if it has no children and no spheres. Because here we say we keep it if it has any children or any spheres. So I think we're looking at doing something kind of like if so if it has spheres, allocate the spheres array. And I guess you want to say else what do we gotta achieve here? It's like, hey, this thing has no well, we don't know if it has any spheres. Because the initial leaf nodes will have spheres. So what we're basically saying here is if we only want to know if this is an initial leaf cluster. This node was an initial leaf node cluster that has no Is that always the case though? It's not. So you wanna go as you go up the tree. Something. Ooh. You want to say node dot on node children bit set equals 0 and has no. In this case, so what is it at this point? What is it that we're deducting? So, what is it that we're deducting? Do I deduct like leaf nodes on leaf nodes? So what is it? This node. Well, it must be a leaf at this point, right? Because the fact is that it has no children. So it must have been a leaf. Right, so he's going to say like, so a dangling node basically. Dangling child node with no spheres, children, something like that. Dangling node with spheres or children as spheres. I think that's right. Okay, so see these numbers are correct. So hopefully the stream doesn't crash. I'll be right back if so. Oh yeah, should have run it in. Alright, we're still running, which is good. Let's see what the GP memory says. Says the volume is, and if the numbers are identical, it means we win. We've deducted too many again. These two numbers should be the same. I wonder if we hit this guy. Should I do a print statement and see what we get? Should I see if we hit this? Oh, hey there, Krez. Welcome. How you doing? 6 months already. Oh, yeah. Yeah, I think I've been doing this thing for about 6 months, maybe. Yeah, how's it going? Hey, have you had a good week? A good start to your week? Thank you so much for the sub. Really appreciate it. So this shouldn't fire because, like, you're only getting... It only happens when you paint stuff down and then delete it, which we haven't done any of that. Something like that. So what is this? So we put this if statement in it, or we corrected the if statement. Say, hey, if it had any children, and it doesn't now. We delete the non-leaf node. Increment and make it a leaf node. Makes sense to me, but I don't know, because GP should be crashing with a... Hmm. So what other case could we be missing from this? If you look at this node and you say it had children and doesn't have any children, becomes a leaf node, non-leaf node. What other edge cases are there? You delete everything, or sorry, you've deleted this node. You've deleted this cluster node because it's surrounded by other clusters. Right, I feel like, um, you delete this child node because it's surrounded by other clusters and we can lower it down. It's just a subtract. Yeah, that seems alright to me. So these are the cases, imagine these are completely surrounded in 3D space by other clusters. You would delete, like, when you get to this one, you'll look over all the children, one thread gets each child, check to see if it's surrounded. Yes, they are. It will look at their final bit set, what it will be like for each of the children. And if these had no children, it will then take away from the leaf nodes. If not, take away from the non-leaf node. That in and of itself, shouldn't you always be taking away from leaf node at this point? Right, the fact you've done this. Right, this is sketchy. If this is a leaf node, which means this is always taking away leaf node. So what is wrong? That is wrong. So it's always a leaf node and we deduct it. That could have something to do with this. And this one's saying like, hey, and then it becomes a leaf node in terms of the numbers. Oh. Right, and then it packs the final bits on there. Okay. Take that for a spin and see how it goes. Hey there, Lobsang2, how's it going? Welcome to the stream. If the stream does, I'll be right back. That's how it happens around here, the AMD drivers suck. Right, we're still here. So let's check the memory again, and hopefully these numbers are correct, right? We need these two numbers to be the same. That's what we're looking for. Please. Right, the make persistent shader, excellent. Go to pipeline state, fish out the volumes. And right. I don't know what happened to that. I think it went a little bit up because it was like 3.7, I think, maybe. But yeah, so this is the midpoint cursor, and this is the number of leaf nodes. They need to be the same. So left of this is where the leaf nodes go, right? So if this number is greater than this number, something is wrong. So we just allocate them at 0 for now. So we're kind of estimating. We're not trying to estimate, we're trying to guess the exact number so we can allocate them properly in a previous shader. So they get initialized to the number of actual leaf nodes here before we run the next shader. We decrement here because this is when it is a leaf node only, yes. I feel like we've decremented too many then. So this is where we set the information. Unless I'm allocating far too many somehow. So we only allocate them when they have any children. We could just do a count as we go up the tree from the bottom. That's probably the best way, maybe. We simply just need to do this if statement and count the number of it should be possible. Right, so rather than like messing around here, let's say we did a different if statement. Maybe, like at this point, you know if there's any children, right? And you know if there's any spheres. So I think you just need to say something like, if so this is like children bit set node. Yeah, so if you have any children, or if you have any spheres, so they're on the actual node, or something like this, then we should be able to do that if statement like we do down here. Where's the bugger? Something like this. If the node is a leaf, if that's equal to 0, and then if it's a leaf, we just add to that one. So we should start these off as 0, and that'll make sense. Wait, this should be a global in the global buffer. Right, I think that, because we're basically making the logic the same rather than trying to sort of work the other way around. Was trying to work from the point of like, hey, we have the biggest number, now subtract until we get the exact number that we want. But instead we're building it the exact way from 0 and just incrementing up based on the same kind of if statement. So that should do it. So we just got to make sure that we set these to 0 here before the shader runs. So potentially then this should probably go when we do the constructor reset shader instead. It just makes more sense that way. There's no decrement anymore. There's none of this anymore. It just, simpler shader is good. And none of this happens here. Oh boy. So hopefully that should be all that we need to do. Right, so the stream crashes, I'll be right back, but it should be fine. Right, it still runs. Now let's check the numbers, and if the numbers are good, we can try and move on to the next. We can commit this and move on to the next task. So that shader, I think, yeah, make persistent, check the volume out. Come on. Yes, the numbers are the same. We're in business. Right. Oh, so this looks good now. So this means that we should have a 256 cubed volume, which has been sort of drawn in, right? And we occupy that drawn space with spheres, and the spheres that fill up this drawn space are very small around the edge, but they're bigger in the as they get in the mid, right? If they're surrounded by other spheres, we replace the smaller spheres with bigger spheres, and we have this whole sort of LOD system, right? And we've seen it in sort of 2D slices, kind of. So we have been verifying that it's probably works, and these numbers seem all right. And so yeah, things are good. So now what we want to do is commit this and then think about how the hell we're going to try and render this thing. So I think I need to somehow plug it into the tile binning shader that we use to do this render right here. Like it's literally binning these spheres into screen tiles, and then we go over the spheres per pixel in the tile, and ray trace against them. So we want to try and see if we can hook it into that system and then just see what it looks like. So let's see what the best way would be to do that. So this is get the make persistent shader working. There we go. Good to know. So let's kind of examine like how. So is it like called the tile bin? This is the UI tile binning. It's not that one. Sphere tile binning. So what it does is it gets a sphere per. It gets a sphere per thread, and then it throws it. It just bins it into a screen tile. So, but we will probably need to get a thread per cluster, and then bin those spheres into the screen tiles, right? I think we can get this system hooked up pretty easy. But this is probably not going to be the final thing we're going to go with, right? We probably want to do. We might want to break it into some temporary. Yeah, we might want to break it into some buffer somewhere. Yeah, copy the clusters into some temporary buffer somewhere and do some inclusion thing. I don't know, but that's a speed up that we need to do later. But now let's try and hook this thing up. So I want to make another shader, and I think we're going to call it like. So we'll take the sphere binning shader, sphere tile binning. I'm going to modify it. We're going to modify it to basically be like that other shader that we've got, right? So underneath the make persistent, we're just going to chuck it in here. And it's basically going to be like that shader. But it will do the binning. So this is going to be volume cluster sphere tile binning. Right. So it bins the spheres of a cluster in the tiles, and then it should just show up and render, right? Um, Legend has it. So I need one of these boys. Should I just write the logic quick? We need to make sure that we clear the bits, the visit bits. They need to be cleared. So in each node, which has a 2x2 of spheres, it has 8 bits to represent which spheres exist, but it also has another 8 bits in that same bit set that represent if this node has been visited yet by its children nodes, and that's if it has children nodes. And this is how we know when to sort of what's the best way to describe this? Here's a good way. The way that the threading logic works, right, is we have a tree of nodes, and we start each thread of a compute shader starts off on a leaf node. So we have an array of leaf nodes, or they sit contiguous in memory. So we just need to know how many leaf nodes have we got, and we can work this information out very easily. So what happens is we start here, and then each one of these threads is going to take all the spheres inside this volume, bin them to the screen, and then it's going to be, and then wait a minute, yeah, bin those to the screen. Maybe we should just start there at the highest LOD. Yeah, it won't be doing the LOD selection. Yeah, maybe the best. Okay. Right, so here's how the algorithm should work. It'll start on these leaf nodes. Then it's gonna check the cluster in view space and be like, is this thing larger than a pixel? And if it is larger than the pixel, it will then bin those spheres to the screen. If it's not larger than a pixel, it will go up. It will go, hang on a minute. And mark its parent, mark the visit bit and say I've visited here. Well, you should probably always mark the visit bit. Gotta be careful. And then your sibling is going to be like, am I bigger than a pixel? Yes, I am. Or no, I'm not. Mark this visit bit. And when the visit bits equal the number of children, so this one set the last one, now it can do the same check and then check itself. Yeah, just thinking about this, doing the LOD selection might be a bit tricky doing it this way. Then it can repeat the same logic again, right, where it, checks to see if the cluster is bigger than a pixel on the screen. I can see some problems with this. No, I'm not using C bindings from GUI. I've just written my own, basically. It's not, it's pretty simple to write your own MGUI, really. Yeah, so I might avoid the LOD selection right now, and let's just get stuff on the screen. So we'll do a dispatch. We won't bother climbing up the parent tree. We'll just terminate the thread. Yeah, I think that's the way we're gonna roll. So basically, we want this logic here. What is that? It's the make persistent part, isn't it? Yes, you need to know, like, hey, they all have spheres there, right? Wait, when did it create the lower LOD sphere? Make persistent refine. Yeah, yeah, meant to make the sphere. Okay. I think we can see all this code here. So I need to pull out a sphere or something like that. So I think if we did 8 threads, oh, where's the dispatch args? Yeah, so on 8 threads here and 4 threads, something like that. That's what we want. We want 8 threads on the X, 4 threads on the Y. So the X is going to be the child index. So you have eight threads per node. Yeah, 8 threads per node instead. That'll be better. Like that. So the Y would be the cluster index. So it'd be like 0 to 3, and that's how we're going to get our node. Oh yeah. We need to fish out the volume as well. Because you need to get the midpoint cursor from the volume. Yeah. Let's move that sphere down into there. Getting in the way. That near clip distance and stuff, we'll need this pixel size at some point. We've already got that information. Right. No. This would be volume cluster mid. Volume. Leaf nodes count. Stop. Well, Steam is kind of cool. Just updated my game and it runs me GitHub. I only changed the files I needed to. Sweet. Yeah, Steam's pretty cool. Yeah, the midpoint cursor. That is now going to be volume dot. Oh my days, it's called volume dot cluster tree midpoint cursor. Okay. Volume dot cluster tree midpoint cursor. There we go. Right. So simply, we just want to, so there's this while loop here, right? Now you've got the beauty of this is, right, you got 8 threads processing the same node. It's amazing. So they should be able to pick up a sphere each and then just bin it in the screen tiles, which would be pretty sweet. So the problem is we don't really have this sphere right here. We need to make a sphere and then transform it. So we don't have. We've got this thing called a volume sphere, which is like this sort of like packed version. So we have to sort of unpack it and compute what we need. And then you've got this sphere structure here. So this is what we need to compute. Radius, center position, color. And we need to compute that from... So the thing is about this volume... So you're rendering in this volume instance, you kind of need to have a, yeah, this definitely will need to get changed a lot, this shader. So we need to do this view from world. So this is when it's in world space. Yeah, this is where we're probably got to use ellipses at some point as well. It will be a bit weird with non-uniform scaling. But let's just build a sphere and just get this ball rolling. So get the sphere, sphere.center position. So this is going to be, I think I've got a way to access the volume. Cluster location, right? You can get the position this way, isn't it? Yeah, you can unpack it. It's pretty sweet. So I can say, hey, give me from this node dot location. And now I've got to add the offset for the sphere. It's this thing here. Wait a minute. That's the cluster. I need to know, based on the child index, what is the offset of the... So here's your cluster, right? There's this position. We need to get the position to get us into the center position there, or there, right? Or the ones behind it in this 2x2x2 spheres. So what do we do to get that? What am I doing to get that? Yeah, it's when I create the initial node. Right? That's it. Here's our boy. No, because that's on the... I need to figure out the order of which way it's done. Right, here's the sphere. Right, so the X is first, then Y, then Z. Yeah, so it's X, Y, then Z, I think. Based on how that works. No, but then this works very weird here. Oh yeah, wait, X. No. Right, but in the refine was the only other place that it did it, right? Right, here's something. Child index mod 2 divided by 2 greater than 3. Okay. Past me seems to have it down. So this will get us our offset, basically. So the child index, we got that, yeah, good. So this is another sort of vector position. $100 to get yourself a Steam page, game, for your information. I don't know if you plan to do anything like that. Yeah, at some point, right, when we have a game idea down, that'd definitely be a good idea to get that thing up and running, right? But until then, like, I want a rendering art style, right? And then I want to know like what we're building. And then after that, it will probably be a good idea to get a Steam page up so we can start accumulating, the wish lists and all that, because that's the points you need, isn't it, to master Steam. But yeah, until that day, there's no point doing it really. Yeah. Yeah, well, you know, Steam's probably the best place to post your game. You just have to sort of know to play their game, isn't it? And get up there. Um, get up there basically. Um, you could go outside the Steam store but you wouldn't really get the customer base because a lot of PC gamers like like Steam, basically. Um, um, sphere radius. Yeah, something I really need to try and do right is understand what I need to do. Yeah, we need to try and make like a small enough game. Find a nice small game I'd like to make. Because part of the problem is, as you can tell, it's very complicated to sort of to make a game. So the smaller it is, the better it would be or the easier it would be to actually get the thing released within a good amount of time. And then I'll probably be able to build a larger one off of this code base. You know what I mean? Because it would kind of suck if I spent, twice the amount of time or 3 times the amount of time than I could have, and then um, maybe not get the sort of results I was looking for. People downloading it or playing, having fun. So probably be better just to do something very small in scope first, and then go off from there maybe. But we'll see how it goes in development, right? Maybe something good happens in development that causes me to do something a bit bigger. I'm not sure. To post on Steam, one should at least have screenshots or something. That's right. Yeah. Yeah, at least have screenshots, exactly. Yep. You should know what your game is, be able to render stuff. Yeah, there's no point doing it this early. Um, so what is the radius, right? I think I'm building in volume space, right? So local space of the volume. So the radius, well, you can get the LOD. That tells you how big the sphere is. But that's the number from 0 to 7. So maybe one should have left it, right? See, I don't know if we should use normalized. So we use normalized coordinates. Because what are we even... Yeah, so it's from within... Yeah, so we use signed norm coordinates, and then we can translate from local space to world space very easy. So this is going to be... So if we divide this by if we divide it by 256, right, I guess that's volume dim. Is that thing? Yeah, 256. So that will give us, 0 to 1 as floating point. Then you want to, but then that gives you a 0 to 1. Now, so how do we work out? So LOD 0, your spheres are going to be we kind of worked this out earlier, right? Their sort of radius. Not this one. Where is it? What did we work out their radius? LOD sphere radius. This is our boy. It's only this sort of maths here. So it's probably something like this. Right, that's probably what we need. So let's work that out. So you basically invert it the other way around. If you got 0, you got 7. If you got 7, you got 0. Right, it's just inverted. So LOD 0 it'll be 7, 1 shift left 7. No, it's a little bit different. Oh, no. Yeah, then it'd be 128 times 0.5, and then that'll make it 64, which is correct. Cool, so that's the radius. Oh, and then because it's made it 64, you then need to do the final divide by volume dim, which is 256, and that'll make it unsigned norm, right? 0 to 1. We'll move that into signed norm space. Yeah, we'll do that now, quick. Multiply sphere dot center position yeah, so we're multiplying it by 0. Wait, it's the other way around, isn't it? Yeah, it's times by 2 take away 1. Yeah, so yeah, that's right. So this one will be sphere dot radius times by 2 take away 1. Voila. So the color, well, I think we have that stored inside the sphere memory, basically. I really don't understand why I've stored the center position in here. It doesn't make any sense. I could just work it out from an index. It must have come from a previous thing which I changed my mind on. So I reckon, right, I might need a very small amount of bits. And the LOD doesn't make any sense either because you're storing that in the node anyway. So I think I only really need like 8. I might only need 8 bits per sphere. Or less. Which would be pretty cool because that can save memory and all that. But anyway, we can just get the as a material index right. We're just going to make them red. So FF000 FF. Just roll with that. So now we've got this sphere in signed norm space, right? Snorm. Now you only want to do this providing that the sphere actually exists. So there is an exist bit. So we want to fish that boy out. So we want to say, right, if node dot sphere array is not equal to volume sphere array invalid and node see, I forget to index this thing. This would be it. Alright, one of these boys. So the volume spheres, no sphere array plus child index. Bam, there we go. So, and that. Then we want to bother to do any of this binning stuff, right? So you get the sphere in signed norm space. We want to translate from local to world. So sphere. So we're going to go from yeah, we need non-uniform scaling at some point, but yeah, let's just do like so we don't really have a volume instancing information yet, but let's just put the matrix in the no. Down these things. Right, we've got a volume instance. So that's what we want, is like this volume instance, and it has, you know, world from local and that sort of stuff, and the, you know, volume index and the material palette. So basically we just want to say volume instance world from local, and then go from world to view, and then we'll do all this sort of stuff here where we bin it into the screen. Just bin it into the screen tiles, and then we ray trace against those screen tiles. Well, no, we ray trace against the spheres in the screen tiles. Each pixel looks at the tiles array. This can go, that's to do with the other shader, which is copied out. This is going to get commented out because we're not going to traverse up the tree. We're just going to render the highest LOD and see what happens. Computer will probably blow up, but it's good to see what will happen. Well, hopefully it doesn't, right? It's only one volume. So now we've just got to get everything plugged in, really. So we need a volume instance. BC volume instances. BC volume instance index. which will just be 0, but anyway, gotta be proper. So let's get this sort of constants thing all set up. What language is that? C. Just C basically. I've got a little custom C compiler, so we can compile C and use it on the GPU, use it for shaders and stuff like that. So we want to read some volumes. We want to read some volume instances, which I don't think I've set up yet. So we'll just upload some, you know, jobs are good. We want some cluster nodes, because we need to go and get those clusters out. We also need the spheres array. And we need the volume instance index. I think that was it. Oh, and we obviously need a way to... So where's the sphere binning? Spheres bin. Bin. That one. So I need to basically figure this one out. What stuff from here do I need? The tile spheres, we're going to write into that buffer. Crap is that? Ooh, what are you? What are you? That was read only? Oh. That's not good. Rewrite. Seclusion, output dims should be enough. Right, so I think we've got all those parameters there. I just want to got to get it compiling and then hook it up CPU side. Show you something running? Maybe. Hopefully it doesn't crash. There we go. So we've basically, this is the old renderer. We're about to hook, well, what's the way of saying it? We've only got a very simple we have an array of spheres and we're just rendering from those array of spheres. But we've been working on a very complicated LOD clustering system for the past month. And we're just plugging it in now to this renderer where it ray traces against these spheres. And this is like a very small amount. What we're about to render is going to be ridiculous amounts of spheres, right? So we'll see how that goes. Yeah, I don't know how many spheres it's going to be, but there'll be a lot. Top binning. Great. So let's close that. So now we just want to try and compile it. See what breaks. Right, so that's not there, that's fine. I do need to run back over this, I reckon. Crap is going on there. Oh yeah, it wants the type. Thank you, sir. Appreciate it. F32 because I've patched them together. Right, calculate outer screen coords. That's kind of like down below, isn't it? That's in view space. Damn it. Right, so this is there's so much code to move around. Or do I move the other... Let's move the other shader below. Here. Let's put it next to the other one. I need to clean up code, but today is not the day. Right, we're just going to drop it in there because I can't be bothered to move other code. I don't know. Keep going. Apparently it compiles. So, let's just make sure that compiles. Yeah, alright. So, let me just double check the shader quick. Right, so we're going over leaf nodes are the Y, children on the X, cluster tree leaf nodes count. We don't get that from the global. That is wrong, because that's for the builder when we build them, but now they're in persistent memory, which is amazing. We get some sort of near clip plane distance and height, so we can figure out some pixel size at near clip. Yeah, we need that layer. What are you hearing? You listen to Stone Rebel. Drop in the chat. Stone Rebel is the bomb. There you go. So get the volume instance, get the volume from the volume instance. If we go outside, if our leaf node is outside of the number of leaf nodes, what should we do? Yeah, we'll return early. Bounds checking. I guess we're going to simply say negative volume dot cluster tree leaf nodes count, cluster tree non-leaf nodes count. Alright, there's a nice safety check. From the midpoint cursor, so yeah, the leaf nodes are negative, right? Normally leaf nodes are positive. Get the absolute index, fire into the array, and fish out our node. If we have spheres and this sphere exists, get the sphere into signed norm space, right, -1 and 1, calculate the, so this would be known as the sphere in cluster space, right? It's kind of not in the center of the object. Is it? No, it is. Wait, it's not in the center of the... yeah, it is. So it's... cluster sphere coordinate. Make it a bit easier to read. So we're adding that to the cluster position, and then we're dividing it by 256. So you go 0 to 1. Convert it to sign norm. Do the same thing for the radius. Do color red for now. Transform into view space. From local to view space. We calculate like how big this sphere is on the screen, get the bounds, go over all the tiles. It's a rough estimate. It's not perfect. Right. And then that's it. That shade looks good. So now I just got to wire this thing in and kind of unpick the other ones because I don't want some of these running, these boys. These sphere tile binning, but the sphere ray tracer tile, that's the one I want. Something like that. Ooh. Alloc then binning, damn it. Do I need 2 of these shaders? No. I just realized there might be a bit of a problem. When we atomically erase an insert index. Right. Yeah, so we do a pre-pass where we figure out like, hey, there's a pre-pass. Calculate the counts, allocate, then bin. So what we need to really do is have there'd probably be a better way to do this. I just want to debug this thing, but the first calculate counts one used to go over and just not add it to the array, but it did the exact same code. Maybe we put an if statement in there and just say, hey, don't actually add it in there, right? Just do something else. And that will probably just do, because I can't be bothered to write, like, copy paste the shader, but then you'll do the alloc guy. We can still use the same shader. What the crap is this? Oh, okay. Yeah, so, right. I got this. Add to the spheres count. Right, I think we're alright. Okay. So add it to the spheres count instead of the... So it is sort of mode, where it's like, oh, we're adding a sphere in here. So the mode will be if... things. So trying to say BC if actually bin, right, or if allocate. Or yeah, if pre-pass, something like that. There'll be a better way to do this rather than running the same shader twice. But for now, I'll just roll with that. If it's a pre-pass, we're just going in there and doing that. And this actually bends it. Fantastic. Right. So now we need to pre-pass Boolean. So we just got to wire all these guys in, and then we'll add an instances array, upload our instance, get a matrix in there, and yeah. Right. So here's how we're gonna do it. So where's the right about here. So we are enabling this, but I want to disable this one. You know, I'll copy this, and I'll disable this one, and I'll copy in the other one which is made. So let's get this all in here. Let's go for ham. Dispatch indirect. Yeah, so dispatch indirect. Where did it get those from? Right, I did like a model instance thing or something like this, right? Fair play. Yeah. See, I don't even know how this new system's going to work, but like, currently we're doing one dispatch per instance. So, like the GPU knows. The GPU knows how much each volume, how many it knows how many nodes are in a volume. But we can always synchronize this information back to the CPU if we wanted to. But yeah, so we could just hard code this value for now, because this requires some thought on how I want to do this properly. But for now, all we're gonna do is just hard code it and just get stuff happening, because I want to see how much this thing actually works, then we can design it and improve it better. So I need all these boys here. So I don't think I have a volume instances one yet, right? I just have a volumes. Right, so let's just plop in here, get an instances one in. And we'll upload the instance to there. Let's just say we've got, I don't know, 32 for now. Well, I don't know what the maximum number is. Hopefully we can have tons. But we've got to work towards pulling that thing off, to be honest. Right, so where's the bugger now? Right, so we've got the volume, volumes, volume instances. We are creating that buff, which is great. Still got to fill it in, no biggie. Volume cluster nodes buffer, where all the nodes live. Got to get the volume sphere buffer, and it goes. This is the tile spheres buffer and the sphere tiles. Lovely names, as you can tell. Tile spheres, which ones are which? So the the instance we're rendering is 0. That one. Output dims. It's this hard-coded number here. Magical. And the grid size. Is this the pre-pass? Yes, it is. And the rest you can just go. Now we've got to deal with synchronization code. No biggie. Oh. So make them all read write, and then we'll just change that. Ooh. Where's the bugger at now? Okay, here they are. So I'll read only, read only. Read write only, read write, write only, read write. Now it's not indirect. And that's not the right shader. That's the right shader. We need some dispatch arguments, right? So the number is here, right? This is the number of leaf nodes. So we could just write this one in, right? 471919, something like that, right? 47. Cool. So with this number, so maybe we don't do that many right away, because this could literally shut down the computer and done, because it's just doing way too much work. Or maybe it's fine. It'd be good to sort of build up to making sure it's all right. Because we might have to heavily optimize this by doing some occlusion system or whatever. And we could be ray tracing against so many spheres here. Or all sorts, right? So we'll probably start off with a very small amount and just see a few clusters. So divide. So we need to launch one across that way. I think that's right now. And then on the Y it was the nodes. 8. And then 1. Something like that. Because we've got 8 threads on the X. No, 4 threads. So that's it. Yeah. That's right. So let's just compile that. Damn it. What's happened? What have we changed? First of all, let's just like make this a small number. Let's just do like 8 nodes. See how it goes. And then why have we? I don't understand what have we changed. Right, it's this, isn't it? Constant data type 0 or 1. That data type 1 is a Boolean. It's probably, yeah, that's right. Anyway, compiler bug. So we don't want to fire it off yet because we haven't done the other side. This then allocate. So this pre-pass here is gonna figure out. It's gonna go over all the spheres, try and put them into the screen tiles, and then it's going to up a count, right? This one's going to actually allocate it properly. And then this one here is going to dispatch the same shader again, make this false. And now this time it's going to properly put them in the bins, right? And then this is the ray tracer shader, which is going to launch. You get array per pixel, and the pixel belongs to a larger set of tiles. Right, sorry, a larger tile. A set of pixels belongs to a larger tile, and that tile has an array of spheres, and then you ray trace over all those spheres. So we could be okay to launch that, but we haven't filled in this instances, right? So we've got the model instances, right? Buffer that we've filled in before in the past, but it's not that one. So I want to take, right. So we can take this, and we can literally just like do it again. This time, rather than model, it's called volume. And rather, yeah, model is volume. And we'll just change all that. Just make sure we're all okay here. So that's creating 2 instances there. I don't know how much a good idea that is. Let's just create the one. Alright. So I think that's everything in place, but sod's law, we've missed something, and it could crash. So if the GPU crashes, we'll be right back. And we should have disabled the, which one is it? We would have disabled these guys, which would have actually binned them into the screen tiles, but they'll still emit into their buffers. But they're not going to, the old render is not going to bin it to the screen tiles anymore. Our new volume cluster thing is. So let's see how that goes. Right. Right, I saw some pixels show up. You see that flash? Something is popping up, but I don't know what. So it's very hard to figure it out, which is... So it is rotating, right? Probably not a good idea. So we should probably just do some identity transform. Transform. Probably just the translation, actually. Just get it away, just get it out of my face, you know? And the kind of the other issue as well is we have, we're only doing 8, right? So should we just up the cluster number? Because we haven't got that many clusters. I don't know how small these things are going to be. There's probably another... Ooh. Yeah, you've made it. Right, let's think about this. Is there a way to visualize it? Probably not. Hmm. So in the ray tracer, we could just color it. You would basically check the... Man, this code is so messy. You basically just check, like, hey, if I have spheres, just render out color, right? So the quick and easiest thing to do would be something like if one and spheres count, so we can disable it, right? Just render out like red. Why doesn't that want to work? Store texture G. Oh, you gotta pack it down into the integer format. All right, let's try that out. All right. Oh, we saw it's in blue. Oh, sorry, it's BRGA. Yeah, so we do the BRGBA. Blah, 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 blah. Yeah. Where is it at? Got now. Oh, there it is. Yeah. Anyway, it's BRGA. That makes sense. So we're seeing the tile show up with something. We can always just turn this off, right? But yeah, so we're seeing a tile. So the tile is 16 by 16 pixels, something dumb like that. Shows up. Oh, there it is. It's blinking. So I feel like they could be very small. Blinking at the lower part there. But I don't know exactly, right? So should we just up the nodes count? Let's go to 128, right? And let's see more nodes on the screen, hopefully. Right, we're clearly seeing a tile pop up way more, and we're able to move and see it show up, right? That's interesting. I moved closer and closer to it, then it disappeared. I think these things could be insanely small. But let's up it to 1,000, right? And let's see if there's multiple tiles that show up. It's actually still pretty quick, which I'm happy with, or maybe it's because it's not showing up on the screen. All right, it still looks pretty quick. I think these things are very small. So that was 1,000. Let's disable this, and let's just see if we get any spheres that we can see on the screen in any way. Maybe they're just a pixel big. I can't see anything. Oh. Damn it. I saw a white sort of thing show up. Problem is we've got this damn sort of free cam on. Should we turn it off? View from. So we did identity, and you put it in front. Just comment that out. So it should just show up now. Can I enable that thing? So it should show the blue. We don't see any tiles show up here like we was seeing. So I've a suspicion to believe that it's identity, right? Well, I don't know if it works anymore. I can stash my changes and delete it and we can find... Should we stash our changes? Right, there goes all my work. But right. So we want where we're looking. Right. So I get rid of this, make this here. Right, so they're right in front of me and I'm moving around, nothing happens. Okay, so they should be right there. Let's just quickly look at the model thing. You know, let's make it so it's just a transform, a translation, no rotation. Is it still the same thing? And if so, that's what we used, that's what we changed in the... Yeah, it just stays there, excellent. Right, so we could probably verify that is true then. Just undo. Wait. Wait, cool. Can I remove that history? Just don't accidentally hit that. Alright, so we got the stash back. So this, you know, we put it in the right place. We definitely upload. We've commented out the view from world. We should be seeing it in our face right now. So we can print out in the buffer and find if we actually just land in anywhere. That's another way. So where's a print? So when we do the binning, this one, right? So do this binning here, and we just want to know, does this happen? Right, bin in tile this. So you should see that like a few times maybe, I don't know. No. It should show up here, we should see it on the screen. But if we were to rotate the camera, so I've got to change that thing. It does show up, right? There it is, right there. So it blinks into, and it's kind of blinking. And we had to get over there. There could be something very weird with... So, you know, we're obviously are binning, so there's something weird. We can get the view space, right? So should we start off in world space? Just see what sort of numbers we're dealing with, right? So sphere.center position .x, y, and z. Alright. Clearly we've got tons of spheres in here trying to bust their way in. Into the screen tiles. So what is our problem? So when you look at that sort of like that volume instance, we put it at 50 x then 200 z, right? So you're seeing those numbers there, which is great. And on the y, it's a little bit of a different, right? Cool. Should we see how big it is in the world for the radius, right? And then we'll put a final one in there. We'll say radius. Let's just see what that boy's like. So this is negative. Well, you don't want radius and sine norm space, do you? It doesn't make any sense, right? Right, it doesn't make any sense. That was dumb. So we'll just write unorm, right? So now when we look at the information, what is it? Now it's insanely small, right? Which is kind of what we was thinking. So now we need to scale this boy up. So what we're looking at now is a thing which is probably 256 or 1 divided by 256, right? These are probably like sub-millimeter spheres or something dumb like that, right? So 1 divided by 256. We're looking at smaller than that. Looking at half that. Right. So if we scaled this by 256, they would be bloody huge. But no, it would be 1 in size. Yes. So what we need to do is have a scale. So where's our boy? Right. So yeah, you want to do something like this. Mold transform 3D. Scale. Right, and we'll do like a uniform scale of, let's just do 64 for now. Should be enough. Right. 64K ought to be enough, you know. And then, you know, we know what that looks like now. It's just, I think we're fine there, so need the print. And we should see stuff on the screen now, so let's see how it goes. Right, we're seeing more screen tiles show up with information here. So this is what the blue means, is the screen tiles, because that's the debugging layer showing up. I guess we can print this out, but it should all be the same. And also, hang on a minute. Hang on a minute. Alright, it's just in front of our face. This is amazing. I don't have to mess with the camera. Right. So we're seeing stuff there now, which is good. But I feel like we're overflowing a buffer. And this is why it's dancing around like crazy town, right? Because if we've said we're doing 1,000 of these, let's just do 8. And we should just see 8. And they should just stay still, right? No. I feel like we're overflowing a buffer somewhere, but I don't know. Anyway, let's just roll with that. Let's disable the... Here we go. Let's disable this rendering... sorry, the visualizer on the tiles. Right. I saw something show up for a second and it's not showing up anymore. Alright, it's showing up there again. Okay. So something weird's happening. I guess should we put this print statement back and just see it look at the data? Right, the data is very, very small data. That didn't bring it up by enough. I thought, oh yeah, sorry. Yeah, 64 shouldn't have been what I multiplied it by. Let's do the 256. That'll bring it up to 1. No, it's not 1, it's 0.5 in radius. Still though. Alright, let's times it by 1024. Let's get it up there in the numbers. Oh, we're seeing stuff now. But it's still dancing around like crazy. Are we scaling? Oh, that's not what we want to scale. They're in the negative? Right, can I put that back to 1? Yeah, something weird happened there. I think I got my transforms the wrong way around. Oh. Well, that was more persistent there, but it's jumping about a bit. But it's still, that definitely messed with the position as well. Oh, I know what the jumping around is. We're rebuilding every frame. Here's what we're gonna do. Memset cluster reset. So static int has built obviously equals false. If not built, build me the volume. Right. So this could crash. It should be alright, right? So I think what that was doing is selecting different nodes every time. In the memory. Yeah, all the nodes are in different orders. So selecting different nodes every time. This one is... problem is the scaling thing again. There's something up. I was getting it from local space into world space. It's in signed norm. I think I simply haven't pushed it out enough. If I push it out by 500 and I'm tilesing it by 256, should be alright. Yes. There we go. So these tiles are holding the spheres and they're not moving. So I should be able to see. Let's delete that. So we should be able to disable this and see some spheres, and they should be red. Well, they're here, that's for sure. Can you see those spheres? They're still blinking like crazy, mind you. Let's see if I can get a screenshot. I seem to be missing the frame when it happens. Maybe it's so small I can't see it in the screenshot. Right, I don't care anymore. So if we scale them up more, they're probably off the screen somewhere. Getting close they kept paying. So I think I got a bit of a problem where I'm scaling them off the like sign norm. Oh, if it's sign norm, this needs to be half the value. Something dumb like that. Alright, that's working better. Alright, now they're a value of size of 1. Times by 512? Yeah, something's off with my numbers. Or it could be correct, just got to think about it. They should be right there. Don't know why I'm not seeing them. So these tiles are being filled. Wait, why is it changing all the time? Oh yeah, because they get built differently. The volume gets built differently every time I boot it up because we've got that code in there. But we should be seeing... so let's disable that visualizer. We should be seeing spheres here. Oh, why isn't it working? So your radius of 1, you're inside norm space. So if we didn't divide this by 2, what would it get? Right, it's the world position. Your radius shouldn't be 1 if you've times it by... Oh, yeah, no, yeah. When you times it by 256, it should be half of... It should be 0.5, right? Because radius is half the... Yep. And if you're making a signed norm number, make it 0 to 1. It's probably what you want. These are probably very small. Should probably move them closer, maybe. Problem is, I don't want them going behind the camera. Maybe I should just render more instances, you know? So let's render... Do we render 100,000? Or let's render like 32,000, see what happens. Yeah, there is a way through render doc, but it's... Yeah. It's faff. Printing is way better. Like, yeah. Like... Oh, step in and step over, right. Yeah, I'm not sure because they disassemble them, isn't it? But then all the code is inlined, isn't it? So I don't think it's easy to do that. Yeah. It's been a while since I've tried to use it. And we're so damn close. Right, we're seeing a whole blob on the screen here of screen tiles. Right, I'll do it again. Right, they seem to be somewhat in the same place. So let's disable that. They might just be so damn small, you know? We can multiply it in the shader and make them. It's working, kind of. They're so damn small, though. Damn it. What am I trying to think about again? Oh yeah, the print code. There's too much printing, so it's just so damn slow. Fills up the buffer. I'm looking for the binning shader. Here it is. Right. So doing that binning is 0.12 ms. Like that's quite slow, to be fair. Wait, that's just for the first time. The second time it's like, yeah, man, I'm all on that. I don't know why that is. Maybe it's cached in cache. I don't know. But yeah, so let's up the number and just see how close we can get to that hard-coded number. So that is already 32,000, right? Let's go up to 100,000. You want to do 200,000. Right, that's up to even more. That's not made it that much slower. Good. Let's go to 200,000. So yeah, this shader, the ray tracer's just doubled in tanking in performance, probably because the pixels that have got the spheres, you know, are just filled, right? Which is fine. Yeah, so it's taking a long time. Yeah, this one's alright. Ideally, I want it to be way quicker than that. Because if we're having many instances of this, not good. So there's ways of us speeding that up by probably doing occlusion or something dumb like that, right? Anyway, that's half the amount. Yeah, so something that I want to do about this, like, should we get the camera controls back and just fly towards it? Since we have it there, and you know, just have a look at it. Dun 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 dun. Right, they're here. Right. Did that make my GPU die? We still going. That was hitting like. Alright, stream's still going, that's good. So it was hitting like really high. That ray tracer was getting bamboozled. Those milliseconds were kind of big, but we had too many spheres per tile, something dumb like that. Maybe we should cap it out at saying, hey, you only have this many per tile. We'll do something like, we'll do an atomic load. If it's less than, let's say, 128, it will still add more than 128, but that ought to be good enough. Or maybe let's say 64 then. Then that'll stop it from completely like lagging like crazy. We'll get more visual artifacts though. Right, so now we're gonna not get any slowdown, but we're seeing like visual artifacts everywhere. To be fair, we're seeing this anyway. But it might be good just to see one cluster then. I don't know. Should we put them all on the screen and see what happens? Because there should be bigger spheres. What am I trying to look for? That hard-coded count, isn't it? Let's just put them all on there. And away we go. Oh, validation error. So we also found another limit. There's too much y-axis, I imagine, on the dispatch. Yeah. Too many groups. Yeah, the way we should solve this problem is... Yeah, the way we need to solve this problem is by somehow selecting the clusters. Like dispatch and select clusters rather than... Yeah, it's possible to do this quite easily. Well, yeah, we should dispatch only along the x-axis, do 32 per... do 32 in a wave. And each thread gets a node, rather than doing 8 threads per node. This is what we're doing here. And rather than binning it to the screen, we need to probably select the clusters that we want to use. And then have this shader go over all the clusters and put them and bin them into the screen tiles, right? So we'll probably, that's what we'll probably do next stream, right? So I think there's some ideas where I want to, like, because at the end of the day, yeah, so I don't know what part is the slow bit, because it's able to, for some reason, right, it's able to run this shader a second time, way faster, and it's writing data out. So I think this could just be the fact that this is loading it into cache basically and running it a second time. Like all those nodes that we're accessing in memory, they get loaded into cache, and the second time around it's just going all at it. So that must be what's going on. But yeah, I think we want to try and find a way where we can do some form of occlusion at some point. But I don't know, breaking it down into the clusters we want to render and then doing occlusion tests over all of those. There simply might be too many of them. But yeah, we'll think about it. Yeah, because this is... Oh. This was doing like 200,000 clusters. Each thread getting a sphere. Right, it's just each thread getting a sphere, running this thing in lockstep. But instead we need to give each thread a node and bin that out to an array. And I thought GPU programming would be a breeze in the park. Oh no. Especially when you're doing like R&D stuff like this, you know, if you're implementing other algorithms, it's still a lot of work and stuff to work out. But when you're doing stuff that people haven't really done before, then it's kind of, yeah, it's a lot of trial and error basically. Right. So I think I've got an idea for next stream. So next stream, we'll write another shader. Always write more shaders. Have a problem? Write more shaders. And we'll do a thread per cluster. We'll make an array of clusters that we want, I think. And then we'll look at is that right? Thread per cluster that we want to render. And we probably want to see how fast it is to do that. Right, append those into a buffer somewhere. And then that cluster needs to be in view space. Right? Cluster in view space. Yeah, I don't know if that's a good idea, because we won't be able to animate it, I don't think, at that point. Yeah, I need to think about this some more. I need to make this go broom. Hey there, Egotist, how's it going? Welcome, welcome. Thank you so much for the sub. Appreciate it, sir. How you been? How you been? There are ways to run this. There are ways to make this do more dispatches, you know, things we can mess around with. Here's the thing. It's like bees, a beehive. I've only seen it flat, right? That's half of them. And some of them are meant to be bigger. I mean, it's some weird glitches with the tiles. Maybe the transforms could be wrong. So they're definitely filling up, right? Yeah, something weird going on. Right. I'm gonna jam and figure out what is going on off stream. Yeah, man, I'm doing awesome. Just finally got this cluster LOD system we've been working on up and running. A little bit slow for my liking, but we're gonna figure out. I've got to figure out my next steps on what we need to do. Probably go back to that drawing board and figure out how do we go forward from here, because we need to gather some information, I reckon, on like, yeah, and then how we try and render these things fast. I think the information as well, we need to verify if the information is correct. Yeah. I'm glad we got something on the screen though, because it's been a while. Right, I think I'll commit that. And I'll put this up on the GitLab for those who are following. So we sort of, you know, get the volume cluster cluster spheres binning into the sphere ray tracer, sort of. Oh, I've just realized. We've got a finite number of spheres in the tile spheres allocator. There's a number for it. Spheres cap, what is that? It's only 40,000. Only. So with 40,000 spheres and we said do 200,000 clusters, that's the reason why it's blinking. Maybe. I don't know. That could be it. Anyway. Right, let's find someone to raid. I'll next be on Thursday at 7:30 PM GMT. Raid Last Miles. The man. The wizard. But yeah. It's gonna be sweet. I think we should find a way to make this go fast, you know? It's gonna be awesome. Right. Have a good Wednesday, everyone. I'll see you all Thursday. Catch you later. Thank you for coming.